So what we're going to talk about in this session is Cross-IDE C# development with PowerBuilder 2017 REST Web APIs. What the Cross-IDE C# development refers to is that once we've created the target in PowerBuilder 2018 and we've exported the data model that we want to from the data windows that we want to use, at that point we could do development in PowerBuilder. We could do it in the C# API that, the C# IDE that Appeon provides, or we could do it with Visual Studio, or we could do it with any other C# development IDE that's out there. It doesn't require that you continue to do the work in PowerBuilder. In fact, you could switch back and forth between the different IDEs, and it all continues to work fine. So, before we get too far along, I'm going to go ahead and show the legal disclaimer, and then we'll talk about the agenda. So the first thing I'm going to do is talk about myself for a little bit. If you're not familiar with who I am, this might give you some idea of why you'd be interested in anything I have to say. Then we're going ahead and create the new C# Web API target. We're going to create something called a data context for it. We'll get into that, explain what that is when we get into it. We're going to generate a C# model from the data windows that we want to use in this new target. At that point, then we create a service interface and an implementing class. Create a controller. We register the service in what's called the startup CS file in the new target. At that point, this service is complete, and we can test it out. And when we're sure it's working, we can deploy it. So we'll cover how we deploy that to the IIS server. And then for documentation purposes, in case you're developing this for somebody else to consume, we can talk about installing Swagger, which is a tool that's used to document REST APIs. And then we have a question and answer session. So first, a little bit about me. I've been using PowerBuilder since the very early days. 1.0b was the first version I started working with. I was working for a county agency up in Santa Barbara at the time, Santa Barbara, California. I decided fairly quickly that I wanted to go out on my own as a PowerBuilder independent contractor, and that's what I did. I did that from 1993 to 2004, so it was 11 years of doing that. In 2004, I joined the company I'm with now, which is called Integrated Data Services. At the time I joined them, they made their primary business was developing a client-server application written in PowerBuilder. We have since migrated that largely to HTML5 JavaScript. However, we do have some customers who still, for various reasons, want to continue to use the client-server version, and so we are still actively maintaining and enhancing that application, and obviously still be using PowerBuilder. But that's actually not where a lot of people know me from. What most people know me from is either because they used to read a magazine that was entirely dedicated to PowerBuilder. It was called the PowerBuilder Developers Journal. I wrote a large number of articles for that magazine. I was the senior editor of it for the last 10 years or so that it was around. The other thing that most people probably know me for, though, is participating in online communities supporting PowerBuilder. So those forums have been available in various forms since the PowerSoft days, even before the internet, when we were on CompuServe. And then the internet came along. We went to NNTP news groups, and then we went to just regular online web forums. And as a result of my involvement in these forums, I was designated by PowerSoft as a member of Team PowerSoft, by Sybase as a member of Team Sybase. Appeon, SAP designated myself as an SAP mentor, and then with the Appeon, they've designated me as an Appeon MPV. All that just recognizing the contributions I make to the online communities. So all that is to say that I've been using PowerBuilder a very long time and seem to be very knowledgeable using it. So there we have the company I work for, and let's go right into how we do this. So if you go into PowerBuilder 2018, Click File, New, go to Target, and there's a couple new targets that show up here in 2018, the C# Web API and C# Assembly. We're going to look in this session at the C# Web API. So once you click on that, you'll be presented with another dialog. And what we want here is we want the Appeon Web API target. That's going to be in C#. I should point out down here, the main thing you do after selecting that is indicate any particular name you're going to give it, where you're going to locate the files at, and what you want to call the solution name. Okay, so that's going to generate this target, which has a lot already included in it. The two main files for a MVC, ASP.NET MVC, sorry, I went too far there. For an ASP.NET MVC program are the program.cs file and the startup.cs file. So we're going to have those. We're also going to have the app settings.json, which is where it's going to contain information like the connect string we're going to use to connect to the database. There's some references here to the .NET Core and to some libraries that Appeon makes available for .NET Core for doing work with PowerBuilder. So this is the program.cs file, and what it is primarily involved in doing is setting up what's called the iWeb host. And this isn't actually what PowerBuilder initially generates. I've added a few lines here, such as capture startup errors and use settings detailed errors true. These help capture additional errors if the web service has problems starting. So I actually added those. Now this line right here, this is where this program, this is what gets run first when ASP.NET Web API app starts. It runs this program CS. This use startup says that it's going to then run the startup file, which is what we're going to look at next. So this is what's generally generated for any ASP.NET Web API target. It's outside of PowerBuilder. There's a couple things here that are specific to PowerBuilder, though. Right here, this use core integrated and use PowerBuilder integrated, and this use data window are added by PowerBuilder to the startup CS to incorporate the additional features that allow it to take advantage of PowerBuilder features. But the two main methods here are configure and configure services, and we will be adjusting those later. Okay, so the question you might be asking yourself at this point is, why are there so many files? Not only are there all the files that were generated originally when we created the target, but we're going to generate a bunch more. We're going to generate the data context, the service interface and its implementing class. We're going to generate a controller. Why are there so many files? Well, the reason behind that is that if you're used to doing PowerBuilder work, you're used to doing a particular kind of object-oriented development. PowerBuilder was originally developed in the early 1990s, and it represents essentially the state-of-the-art in object-oriented methodology at the time it was originally developed. What happened, though, is that object-oriented development has actually moved beyond where PowerBuilder started, and so a lot of the new techniques that are involved in doing object-oriented development aren't immediately available to us in PowerBuilder. And one of those is design patterns. It doesn't mean you can't do this kind of stuff. It just means that PowerBuilder isn't necessarily architected to make it readily available for you. You actually have to do a little work to get there. So one of the design patterns, the one that's become very popular, is what's called the Model View Controller design pattern. What that is, and here's a a couple links here if you want to dive into details about that particular pattern. But it actually touches on this next subject. There's principles called solid and grasp, some of the more recent object-oriented methodologies. And the S in solid stands for separation concerns, and that's part of what model view controller is about. Is that you tend to, what you want to have in any object-oriented design is that you want to have specific classes that handle one specific thing. So you have a class that is only concerned about getting data from the database. You have another class that's only concerned with presenting the data to the user. And then you have another class that is responsible for getting those two classes to coordinate. And that's really what model view controller is. Model is the class that is only worried about communicating to the database. It doesn't care and doesn't know about the UI at all. Your view is the UI, or whatever provides the data to the user. It doesn't know anything about where the data came from. It's just worried with getting the data to the user. And the controller is the thing that gets those two other classes to talk to one another. There's also the idea of composition over interface, and I've got a link for that as well. Composition over inheritance. And what that's about is, and we go touch on this next screen, is there's some issues that you've probably experienced as a Power Builder developer. One of them actually built in right in the Power Builder IDE is the fact that there's a data store, which is non-visual, and a data window of control, which is visual, and they don't have a common ancestor. They have a lot of the same methods, but the only real common ancestor for them is PowerObject. And PowerObject doesn't share many of the functions that these two lower classes do have in common, but they aren't in common because they're inherited from a common class. They're just in common because the developers that did the IDE coded the same methods on both, which is not a particularly good way of doing code reuse. Another example of some of the issues here is, let's say you go out and create an object, and then you declare an ancestor from it, and then 9 months down the road you realize that you inherited from the wrong parent object. This object really should have been inherited from a different parent object because the behaviors that it has are really more aligned with that other object than the one you started with. And in Power Builder, that's kind of a nightmare. You actually have to go in and do some edit source if you're gonna try to deal with changing inheritance. Or you create a set of objects and you have a couple different inherited branches. Let's say one's called A and one's called B, and everything's working fine until you get this object C. And this object C that you need to create, it turns out it needs to have behaviors of both A and B. Well, what do? Because you can't inherit from both branches. You can only inherit from one of them. So it's kind of the inheritance model that Power Builder implements doesn't necessarily lend itself to dealing with those sort of issues. So what's done primarily now in more modern object-oriented development is the idea of interfaces. So with an interface, you declare a set of properties that aren't implemented, and then in your classes you indicate that the class implements one or more of those interfaces, and then code the appropriate interface. And that allows you you can inherit from multiple interfaces. That gives you essentially the idea of multiple inheritance. And if you want to change the quote-unquote ancestor or that this thing implements, you basically just change the interface in the declaration. It's not a big deal to change essentially what the thing's inheriting from, or the interface that it's actually implementing. So what in our model, go back to model view controller for a minute. The model has the data context class. That's the class that actually knows how to talk to the database. There will be POCO classes. POCO means plain old CLR objects. So it's just basically like a structure that has simple data types declared, and that's used for data transfer between the layers. It doesn't know anything about the database. It doesn't know anything about what the front end is going to look like. It's just this simple class. And the data access classes, which actually go and get the data and return the POCO objects. There's the view. That's in this case, because we're doing a web API rather than a UI, the view is going to be our service interface, what returns the data to the user. And then we're going to have the controller that basically coordinates getting the data out of the data model and giving it to the service. So how do we create a data context? We go into the target, select new folder first, and we're going to call that folder model. This is typical for any MVC application, is you'll find folders actually named models view controllers, or views controllers. And then we're going to create a new item underneath that folder, and we're going to select the Appeon data context from the dialog that appears. And what that will do is that will actually prompt us for the database connection that we're going to generate this data context from. And so, and then what I'm using here for this example is I'm using the AdventureWorks sample database for Microsoft SQL Server. At that point, it will embed that information in the app settings JSON file as for the connect string, and it will create this data context file. I wouldn't necessarily recommend you call it data context like I just did. You might give it a more meaningful, employee data context or something like that. But anyway, and this is all generated for you. And it's basically complete at this point. There's really not more you need to really do here. So then we're going to go in and generate the C# model. So this is a Power Builder, classic Power Builder application up here, which has this employee data window, which looks at the employee table in the AdventureWorks database. Right click on it, and you select this new option. It says Generate C# Model. And what it's going to do then is it's going to show you this C# model, and there's an icon right up here that does the model export. So we're going to click on that, and it's going to ask which other target in this workspace do you want to export that C# model into. And so I'm going to select the Web API C# model, and I'm going to indicate that I want to put this in the folders folder. I'm sorry, the models folder. So what we end up with is this somewhat deeply nested structure here. There's our models folder. There's and actually a reference to the workspace, to the target, to the Pibble, and then there's the syntax. That's the exported data window source. And this other file, that's our POCO object. So you can see it here. Basically, it's just a bunch of variables in a structure. It's called class, but think of it in terms of as a structure. And then the individual elements of the structure, which are simple data types. Okay. We're going to go back. Remember that startup.cs file? We're going to go back to that, and we are going to add a reference. In this case, I'm going to add a reference to the SQL Server libraries because I'm using SQL Server. And then in the configure services, I'm going to add a add data context method. Don't go so fast there. We're going to add the add data context, and I'm just going to give it the name of the data context class I created. And this is why I say don't call the thing data context. I had to fully indicate the full, not just the class name, but its packaging, in order to keep the Power Builder from getting confused with the actual original data context class. So if you did call this, let's say employee get data context, you could have just said employee data context here, and Power Builder wouldn't have gotten confused. And then I tell it to use the connection string AdventureWorks, which is in that that app.settings.json file, which has the connection information to the database. Okay, so now we're going to create a service. So I'm not going to call my folder here view. I'm going to call it services because that's actually when I'm creating our services. So I create a folder called services. Then I do a right click on that folder and select a new item. And the first thing I'm going to do is create an interface. Okay. And that interface, all it's going to have, I'm going to add the Appeon.PowerBuilder include up here. And then I'm going to create the methods, or the prototype for the methods that I'm actually going to be implementing in my service. When this interface first gets created, it will just say interface in the name of the interface. You'll need to add the word public in front of that interface, or we'll run into problems later. And then in this particular example, I'm just going to do a get all that just returns all the employees. The return type is going to be iDataStore, and then I'm going to take the iDataStore back as an argument for my update method, which is just going to return an integer indicating whether or not the update worked. Okay, now that I've created an interface, I'm going to create another folder underneath my services called impl, which is going to have the actual classes that implement my various interfaces. I'm just doing one particular service here, but as you develop this web API, you would develop additional services and additional controllers for those services. Right-click then on that impl folder and select class and give it a name. Now, what you'll end up with is basically just public class and a class name. What I'm going to do then is add a colon in the name of my interface. Then I'm going to just copy in the methods from my interface that I'm then going to implement. Now, once I've copied them into the class, I need to add the public keyword in front of each of them, because these are the ones that are actually public on the interface that I'm implementing. I'm also going to use a couple of include statements here, or using statements, because I'm going to be using some Power Builder specific features here inside of these methods. Now we get these squiggly lines here right now because Power Builder knows that these actually have to be like this one actually has to return an iDataStore, and right now it's not doing that. Or this other one needs to return an integer, and it's not doing it yet. So these haven't been fleshed out yet. We're gonna be do that in a minute. So before we get to that, though, what I'm going to do is I want to declare a private variable within the class of my data context. Now this is my data context class that we created earlier, and I'm going to create this is a custom constructor for this class. So the normal constructor wouldn't take any arguments. This custom constructor takes an argument of a data context class and assigns it to that private variable, because we're going to use that data context later to get the data. So this is what the methods look like when I actually fully code them out. So I'm creating an instance of the iData store, and I'm using the new data store, and I'm giving it the name of the data window. Remember, the source code for the data window is exported into the model, and so I'm just referencing that. And I'm giving it the data context, which is essentially my connection object to the database. At that point, I just say retrieve the data. So this should look very familiar to Power Builder developers. And I'm returning the data store directly back out of this method. For the update, I take in the data store, I'd set data context, and basically this is a setTrans object. I'm giving it the data context, which is essentially my database connection. And I just issue an update statement and return the result of that back out of the method. So now we have our model and we have our service. We need the controller that kind of puts everything together. So we're going to create a folder called controllers, and then we're going to do a right click on that and say new item and select controller from the dialog that pops up. And that's actually going to create a controller that has a lot of pseudocode already generated for us that shows us what the control, gives an idea at least of what the controller should look like. So it threw in here a get method that uses the HTTP get verb for getting, in this case it just returns a single value. This one actually takes an argument, returns a value. This one takes a post, which essentially means it's an update, takes a value in. This isn't what we're going to use, but all we're going to do is take this and modify it to give us what we really need. So one of the things I'm going to do first here, though, is I'm going to add a reference to my services class in my controller with the using clause. And then I'm going to go in and create a private variable of the service type, and create once again, this is a little familiar from what we did with the service. The service referenced the data context. Now the controller is going to reference the service. So I create a local variable of the type of the service, and I create a custom constructor which takes the service as an argument and sets it to the local variable. Now I'm going to take that original get method that they provided in the template code. I'm going to change that to get all, because that's what I happen to call my method in the service layer. And I've got a couple more using clauses here because I'm going to be using some more of these Power Builder specific types here. For example, this iData packer is comes out of the core service Appeon core service library. So I've modified that to return iData packer rather than whatever it was originally returned, and renamed the method. And I took out the code that was originally here where it returned a string value. I'm going to do the same thing with the actually there was other methods in here, the get and put and delete. I'm deleting those just because I'm not implementing those. More full featured API, you might implement those as well. The only other one I'm worried about is what was for the post method. I am going to rename it to update because that was what I had in my service layer. And I'm going to change what it returns to the iData packer as well, the same as what the get all returns. And then I'm going to change the argument to be iData unpacker, and remove the code that was originally put in here from the template. So these are the two methods I'm going to implement on the controller. This is what the getAll method is now going to look like. So I'm going to create an instance of a data packer. I'm going to add a data store to it. This is just a name I'm going to give it. And then I'm going to call my service and a method and actually get the data. Then I'm also going to add a value, and it's just going to say status 200. That is the HTTP. This thing worked. It's the OK code. So those are the two values I'm going to return in the iDataPacker, and then I'm just going to return it out of this method. Same thing with very similar, I should say, for the update. I'm going to take my service. I'm going to issue the update statement, and I'm going to say get data store using that same name I used to send the data down to the client. So it's going to unpackage the data that was sent to me and essentially create a data store out of it, and then issue the update statement. It will get the number of rows that were updated back out of that. I create another data packer, add the success code, the 200 success code, and the only other thing is, as I'm returning, is the number of rows that were returned in the update, and then I return that back out of the service. Okay, now I'm going to go my services, my startup CS file. Every time I create a new service, I need to add it to the configure services method. So I say services add scoped. I give it the name of the interface and the name of the implementing class. So you might wonder, how exactly does the controller determine what URL we need to pass in order to call the particular methods? And that's handled by the route tag that's at the very beginning of the controller. These are variables that are stuck into the route so that you don't have to actually code URLs for the specific method. What this will do is it will just look to see what the controller name is, strip off the word controller so that this becomes employee, and then it will take the method name and it'll include that there. So if you have, in this case, the getAll method of the employee controller class, what you'll end up calling in order to call that method is API/employee/getAll. Okay. At that point, we can run it. And I mentioned earlier the idea of the Cross-IDE development. Up until this point, I was using the Power IDE to do all this work, and as I mentioned earlier, you could have used C# IDE that Appeon provides. I could have used Visual Studio to do, except for the exporting the data model. You have to do that in Power Builder. But all the rest of the work that I showed you, although I did it in the Power Builder IDE, could have been done in any of the various IDEs. And what I'm showing here is that I've actually opened up, this is the C# IDE that Appeon provides, and I've opened up the target in that, and I've just hit the F5 key, and that causes the service then to be run in the context of a command window. And you'll see here that it's listing on localhost 5000, and then I've opened up a browser and I'm used that to navigate to the URL that was specified in the controller. And as you can see, I'm getting the JSON back. This happens to be in another session I cover the different JSON formats that Power Builder generates. This is the standard data window JSON that it returns. This is the indication that this is my employee data set, and so you can have multiple data sets being returned. Now, if you don't have to necessarily use the C# IDE. If you want to only do your development in the Power Builder IDE, You can't hit F5 in PowerBuilder and have the service run, but what you can do is you can go to the directory in with you when you built the project. You do need to copy the app-settings.json file out of the original directory it's in into the bin directory where the assembly's at. And once that's available there, you can actually just run the assembly from a command window just by issuing the command right here, .net. That's it, and that's the dot is spelled out, .net, and the name of the assembly, and that will launch the service once again, listening on port 5000, and once again you can open up the browser and navigate to the URL that the controller's listening on, and it will return the data to you. If you don't necessarily want to use the browser to be testing out your services, a great alternative is a product called Postman. It's open source. You can just download it. Oh, a little too far. It's great because you can create collections, and then you can store off the different API calls that you've created with sample calls, and see the response actually formatted a lot better in Postman. Okay, so now we've got a working service. What we want to do is deploy it. And to do that, what we can do is we can right click on the target and select Publish. And there's a couple options here. There is a web deploy and file system. Web deploy assumes that you have direct access to the IIS folders that you want to deploy this target to. For my demonstration, I'm actually going to deploy this to Amazon Lightsail, which means I don't have direct access to the folders. I have to copy the files there. So what I'm going to do is I'm going to do a file system deploy and just pick some directory that I want it to deploy the files to. And then you do the deploy, and if you look at the output pane, you'll see the results of the deployment. So that gave me a set of files. I zipped them up. I transferred them to the Amazon Lightsail instance. I unzipped them into a folder on that server, and now we're going to go ahead and configure IIS so it recognizes that as a web service that it's going to expose. So what I do is I go into the IIS manager, and on the sites folder I click Add Website. Give it a name, and I point it to the folder that I unzipped the deployment files into. And then I need to pick a port on the machine that's not being listened to for anything else. In this case I picked 88888. And at that point, what you might want to do is test it locally, and that's what I did here. Is I navigated to localhost 8888 and used that same URL, and sure enough, I got data back. So this is telling me that on my IIS server, this server is working correctly. The service is working correctly. But something I'll point out here: if you go on most Windows Server 2016 machines and fire up IIS and query a service that returns JSON, what it'll ask you to do is ask you if you want to download the file. What I did, so in order so you could see that JSON that you can see there, is I had to tell Internet Explorer how to handle JSON. The way you do that is you change a registry setting on the server. You go into key classes root, MIME, database, content type, and add a key for application/JSON. And in that key you've just created, you're going to create a couple values. You're going to create a string value of the CLSID that I'm showing here, and then for encoding, you create a reg binary of 08000000. And at that point, then when you run IE, it will actually display JSON in the browser. Okay. And the next step, okay, we've got this service running locally, but in most cases, when you're in a production environment, Windows Firewall is in effect, and it's not, although the port 8888 in this case worked fine on local machine, nobody outside is going to be able to get to that because the firewall is going to block them. So what you need to do is go into the Windows Firewall, indicate that you're going to create a new inbound rule. So you go to inbound rules, click new rule, and we're going to indicate we're going to open up another port. Indicate that it will be a TCP port. Indicate the specific port or ports that you want to open. In this case, I'm going to be opening up 8888. In the next part of the dialog, you just say you're going to allow the connection. That's the default. The next part, it'll ask for the profile. Once again, accept the default, which is all checked. And then give it a name. So I'm going to call this PowerBuilder 2018 Web Services. That's my new rule on my firewall that exposes the port to the outside world now. Now, in the case of Amazon Lightsail and probably a lot of other production hosting environments, that exposes the physical machine, but it still doesn't necessarily allow the outside world to talk to that machine because Amazon is running, in this case Amazon, is running their own essentially firewall on the interface between Amazon and their server cluster. And so what you need to do is I've gone into the settings for my Lightsail instance, and I've created a firewall exception here as well, which exposes 8888 to the world for my server. So what I did here is there's an add button down here below you can't see. I clicked add, it opened up a new spot. I indicated that I'm doing a custom application rule, TCP, and once again 8888. And that makes the port available to the outside world. So now I can go and actually hit my service from the outside world and actually see it return data. Okay, so now you've got your service deployed out there in production, so other people can use it. They need to know how they're supposed to use this service because, like a SOAP web service, there was something called WSDL files you could generate, which would let other people know how they're supposed to call the service. For a REST web service, what you generally get is human readable documentation. So what you're going to have to do if you're going to expose this service to other people for other people to use it is generate that documentation. What's really popular right now, it's not a standard, but it is very widely used, is a tool called Swagger. And what that does is that Swagger is actually installed as part of your application, and then it creates a UI that the users can call to explore the services that you've made available. So in order to do that, now I'm back in the C# IDE because I need to get to what's called NuGet, which is how you install packages in Visual Studio. And so what I've done here is I've gone into the tools and then there's an option for the NuGet package manager, and that's what this is. And over here I've indicated that I want to look for what's actually called swashbuckler.asp.NET Core, which is the .NET Core implementation of Swagger. And once it finds that, I select it over here and indicate that I want to install it, and it automatically installs this as another referenced item. Now once again, you don't have to do anything through the .NET IDEs, the C# IDE provided by Appeon or Visual Studio. If you just still want to just use Power Builder, what you can do is you can go out to the command line, go to the directory that your project is in, and use the NuGet command line utility at the command line to install the Swagger package. Now what I'm going to do is I'm going to go into the startup class. I'm going to add a reference to Swashbuckler, and then I'm going to add another line to my config services file, which says services.addSwaggerGen, and then this next statement. And you can actually change this around. This is kind of the default they give you for getting started. But there's a version number here and whatever title you want to appear on the Swagger page. So, and then we're also going to go into the configure method and add app.useSwagger. And this next one is optional, but this is what will give you the page, is app.useSwaggerUI. And what you do in this particular call is you actually indicate what endpoint is going to be added for the UI to appear in. And this is once again sort of the default they give you, but you can make this whatever you want. But the default they give is /swagger/v1/swagger.json. So you add that as well. You recompile the service. Oh, actually, before you do that, Swagger needs a little help in order to document the methods. So I'm going to go back into my controller, and I'm going to add some decorations to the methods to make it clear to Swagger where the arguments to the methods are coming from. Because what Swagger does by default is always assumes that arguments to the method are coming from the query string. And in the case of, let's say this is a post, this is actually a block of data that's being sent as the data in the post body, not in the URL. And so I've added this declaration here, that this from body declaration, to indicate that that's where that particular argument is coming from. At that point, like I said, you go ahead and recompile the application, and now when you go to access it, I say localhost 5000 again, because that's I'm testing it here locally, and that's the port it's listening on. But now I give it that /swagger, and it responds back with this documentation that was automatically generated. This is that employee method that we had, where I have the get all and the update, and if you click on those, actually will drop down and give you additional information about the call, each call. There are in this particular method, I return and accepted an iData store as arguments. Appeon also supports using what's called the model mapper and the model store, which I'm not going to get into for this session because this session is going to run long anyway. But I've got in the sample code, I've got services that implement those other two alternatives as well. So when you can grab the sample code from the conference website, you can look that over and see how those other approaches are done. So that's what Swagger looks like. So that's something you can give your the people who are going to consume your service, so that they know how to call your service, and you don't have to spend a whole lot of time writing documentation for it. Okay, So that's essentially it. Before I go, though, I wanted to cover one other thing, not specific to the web API, but as I mentioned earlier, there are community forums people like myself participate in, where when people have questions about Power Builder, they can go ahead and ask their questions and get answers back. And where we do that typically nowadays is on the community.appeon.com site. And it's not just discussion forums. There's tech articles up there, tutorials, there's videos, all kinds of good information about how to use Power Builder. So if you're not already familiar with it, I'd really recommend checking that out. And with that said, I thank you for your time.